Welcome friends. Today we will start the fifth unit. The main topic is reciprocating air compressor, and next topic is rotary air compressor. There are two classifications. Uh, we will only focus on reciprocating air compressor. The rotary air compressor is in the self-study process. Okay. Reciprocating air. What is first? First we know what is compressor. The compressor is the opposite prime mover or opposite of turbine. A turbine consumes high pressure steam and develops electrical output through rotation. Here the high pressure steam is that energy is converted to mechanical energy. Okay, but in a compressor medium, here we need the compressed air is the application. But then the rotation, the electricity through rotation is the application. But here the application is the compressed air, because the application of compressed air role plays a vital role in many industries and our daily life. In every petrol pump having compressed air system, because for our two wheelers and four wheelers needing compressed air. Okay, for vehicle movement. Therefore, the application of compressed air is very vast. Therefore, the compressed air system also very important for daily life as well as industrial purpose. Okay, air compressor is a machine which takes an atmospheric air, compresses it with the help of some mechanical energy, and delivers it at high pressure. Yeah, okay. It's also called air pump. It's not a clear name, but in the book they are mentioning, but the name is not a clear name. Okay, the correct name is compressor, air compressor, because air is compressed by the mechanical device. That device is called air compressor. Okay, then see the diagram. Here the one prime mover. Prime mover means the compressor is connected with the motor. That motor consumes electricity. Due to the consumption of electricity, that motor is rotated. That rotate that motor is coupled with that compressor. Then due to the rotation action, the compressor sucks the air and which is the sucks the air, and due to the area variation in the outer casing, the compressor compresses the air and delivers the high pressure air to the certain application. Okay, and during compression certain amount of heat is released. Everybody knows. Okay, during the compression process heat is increased. Remember the auto cycle, diesel cycle, isentropic compression time, temperature increases. Okay, this is the actual concept as well as the real concepts. Okay, and many of the uses are listed here of compressed air. Okay, then air refrigeration and cooling large buildings, driving pneumatic tools in shop like drills, rivets, screwdrivers, and driving air motors in mines, electric motors and IC engines, air motor in mines, as well, and also in our borehole making machines. Also having compressed air system to bore a hole inside the earth to better groundwater. Okay, this is also one of the application. And IC engines cannot be used because first is due to presence of influent gases, then training purpose, blast furnaces, spray painting, you know. Okay, and hard excavation work, tunneling, boring, mining, and starting of heavy diesel engines. Heavy diesel engines means train engines. In ancient days, all engines of railway transportation there are diesel engines, but the diesel engine capacity is very high. Consider 150 cc bike engine started through a kick, self kick. This is this is also very difficult for many persons. Consider bullet. It's a 350 cc engine, but in railway engine, each engines railway engine having many cylinders, like uh, single cylinder engine. It's a multi-cylinder engine. Therefore, nearly 12 cylinders are there. Each cylinder capacity is for nearly 15 liters or 25 liters. 25 liters means liters convert to cc is a very large. Okay, therefore the starting problem also very large, because we cannot start with kick or self start. Okay, because the capacity of the self start motor is very high, and also kicking is not possible for that particular large capacity engines. Okay, therefore how we start the engine is we the application of compressed air. First we supply the compressed air to the cylinder. Through the compressed air, the piston downs and the engine is slightly rotates. Then slightly rotates, which means automatically starts. You will know. Okay, while we pulling the diesel engine slightly, the vehicle is started. Likewise, we supply the compressed air to the one of the cylinder, then the cylinder is pushed down. Before the remaining cylinder is pushed up, then spark is ignited or diesel is ignited, then engine is started. Okay, so through the compressed air system alone, that heavy type engines are started, and ship engines like. Okay, then inflating automobile and aircraft tires, supercharging of internal combustion engines, and conveying solid and power material in pipelines. These are some applications of compressed air. Then some more applications are listed here. I skip the applications. Then second is classifications. The main classification is rotary air compressor and reciprocating air compressor. Okay, rotary air compressor. Rotary air compressor, all of you knows, because we will experiment on that in our thermal lab, rotary air compressor. Okay, reciprocating air compressor also there in our thermal lab, but we didn't any experiment on that. Okay, but rotary air compressor, we have a vanes, and reciprocating compressor like engine cylinder, having piston and the casing, but elimination of spark plug and fuel injection systems, because it's a compressor, it needs compressed air alone. But engine concept is totally different. It develops energy output, but in the case of compressor, it develops high pressure steam, high pressure air only. Okay, therefore there is no need of spark plug and other things. Okay, but the same structure like AC engine. Reciprocating type compressor, rotary compressors are having vanes, number of vanes having, the vanes sucks the air and compress the air and deliver to the particular location. Okay, but rotary air compressor cannot be used as a high pressure compressor. High pressure compressor is high pressure compressor is achieved through the reciprocating compressor. Okay, rotary compressors are low pressure creating compressors. Okay, we cannot create high pressure in the rotary compressor. Okay, it's from the reciprocating compressor alone. Okay, then the compressors classifications: the positive displacement time and dynamic compressor, reciprocating rotary and single acting, double acting, roots blower and van type blower, and dynamic compressors, centrifugal compressors and axial flow compressors. Okay, these are the positive displacement and these are the dynamic compressors. Okay, there is some classifications of compressors. Then reciprocating compressor terminology. Some common terminology used in a reciprocating compressor. Okay, single acting compressor. Okay, single acting compressor means it have sucks the air in one direction. alone. Okay, I explain with the diagram later. Okay, here you understand singularity compressor sucks the air with only one direction. Okay, then double acting compressor sucks the air in two sides of the piston. I explain also that two concepts with neat diagram later. Then single stage compressor, multi stage compressor. In 1 and 2 is double acting, single acting. Okay, but here single stage and multi stage means integrating compressors. Single stage compressor having one compressor. Multi stage compressor means number of compressor in series. Okay, like bulbs connected in number of, so by the bulbs connected in a series circuit. Okay, then pressure ratio is defined as the ratio of absolute pressure and discharge pressure. It is ratio between inlet pressure and exit pressure. Okay, then free air. If the air exists under atmospheric condition, free air means there is no compression. How much amount of air is inside it and how much amount of air is exited. Free. During not running condition, the air is inside it and the air is outside it. It is called free air flow. So during not running condition of the compressor. Okay, then compressed displacement volume. Compressor displacement volume. Compressor displacement volume means already we discussed about that in IC engines. Displacement volume is stroke volume. Is volume in bar, stroke length and diameter of the bore. Because the construction is same with IC engine. Already I said. Okay, therefore that displacement volume is also called stroke volume, which is equal to 5 by 4 d square L. Here d is stroke bore of the compressor and L is the stroke length. Okay, then the induction volume rate or volume flow rate. How much amount of air is flowed per second? It's called volume flow rate. Is volume inducted per cycle, number of induction per revolution, and number of revolution per second. Is a formula. Okay. Is for single acting reciprocating compressor, P is equal to 5 by 4 d square L into n by 60. N by 60 is only added. The displacement volume is 5 by 4 d square L and the volume for it is multiplied with speed. Okay. A ln by 60. A is cross section area, L is stroke length and N is speed. To convert the RPM to RPS is divided by 60. Factor is included. Okay. Then the singularity reciprocating compressor, the volume flow rate is the formula for the volume flow rate is ALN by 60. ALN by 60. ALN by 60. Here the A is pi by 4 d square and L is torque and N is speed. Okay, for double acting having air sucked air both side of the piston. For double acting reciprocating compressor sucks the air in both sides of the piston. Okay, it's only difference. Therefore, 2n by 6. Stroke volume is same, displacement volume is same, but speed is considered for two multiples of 2 because two sides of the piston sucks the air or uses a compressor. Okay. Therefore, the formula is 2 ALN by 60. Okay. Then capacity of the compressor. Actual quantity of air delivered per unit time at atmospheric condition is capacity. Then free air delivery, already I said, discharge volume of compressor corresponding to ambient condition, which means not working condition. Consider a flow through the duct. In the inlet valve sucks the air and the exit valve deliver the air. Both valves are opening condition. Consider, assume both valves are open, then at the situation that pressure is doesn't rise, therefore it sucks the air and delivers the air without pressure. That air is called free air delivery. Okay, FAD. Then piston speed. The linear speed of piston measured in meter per minute is expressed as 2L. Okay, piston speed. Another important parameter. Velocity of speed. Velocity of speed is equal to 2Ln. L means stroke length and N is speed in RPM. Okay, but piston speed also indicated in meter per minute. Therefore, there is no need to convert RPM to RPS. Okay, then these are the main uh, nomenclatures or main concepts are available for the reciprocating air compressor. Okay, suppose you want to do, I want to know the major parts for major nomenclatures for rotary air compressors is for yours. Compressed air system. Main components of compressed air systems. Uh, then intake air filters, interstage coolers, after coolers, air dryers. These are the main additional accessories for a compressor air system. Okay. Then single acting respirating compressor. Single acting or single stage. This is a single stage or single acting respiratory compressor. Here the inlet valve and exit valve are there. Okay, the piston is there and water jackets are available because during compression the high pressure created and pressure is directly proportional to temperature, then temperature also increases. Okay, to cool the piston valve due to the rising of the temperature, the water jackets are available and in that valve and our exit valves are available for suck and deliver the air and BDC and TDC and above TDC there is a volume which is called clearance volume. Okay, then now we see some in next class or next video we discuss some derivations related to considering clearance volume and non-considering clearance volume. Okay, the piston top of the piston touches with the top of the cylinder. This is one concept, and top of the piston is not touches with the piston. It lies a particular distance between the top dead center, top face of the piston. Okay, already I said many times TDC and PDC. TDC is topmost portion of the piston, PDC is bottommost portion of the piston, and TDC is matched with top plane of the cylinder. It's called without clearance, and TDC is not matched with top portion of the cylinder and is just below the cylinder. It's called considering clearance. Okay, which is in between the topmost plane and TDC. That place covered by that area is called the clearance one. Okay, and the volume in between the TDC and PDC is displacement volume. Okay, this is a single acting and single stage respiratory compressor. Okay, here in the top of the piston alone sucks the air and delivers the air, compressed air. This is the one type of compressor. Then double acting compressor. Consider double acting compressor. Here this is one space and this is one phase. Okay, the double acting respiratory compressor. Air sucks and air delivers. This space like imagine top as one part of the compressor and bottom is same structure of the another part of the compressor. Okay, then in both bottom and top producing compressed air. Okay, so this is the another type is double acting reciprocating compressor. Okay, Working of the reciprocating and doubleting and singulating compressor in detail is given in the book. You can refer the book and to know the exact operating principle of single acting double acting principle in detail. Okay, this is the PV and PV diagram for a reciprocating gas compressor. During compression, okay, one is starting stage as air is sucked and two is uh, exit of the compressor. Okay, here we don't consider clearance. Okay, we don't consider clearance. Clearance, which means uh, we don't do that piston top of the piston is merged with the top plane of the cylinder, and from that cylinder alone that the first stroke is suction, means from top plane to piston moves gradually to bottom, and when it reaches the bottom and full air is uh, collected in the cylinder, then inlet valve is closed and exit valve is closed, then the compressor is uh, starting compressed action, and from 1 to 2 pressure is raised, then from second point the exit valve is open, then it reaches the particular place and the exit valve is open, then high pressure air is delivered to the particular application, then the piston touches the top plate. Okay, here they are not considering the volume of volume after TDC. Here TDC and the top plane of the compressor is cylinder is same. Okay, it's a first assumption, but in not actual case it's not. Okay, there is some volume in between the TDC and the top plane of the cylinder. Okay, but here is a simple assumption. Okay, this is just one concept. Through this concept, you can derive one derivation. Process C21 suction stroke, and process 122 polytropic compression, and process 22D discharge compressor air flow function, and process B2C no air in the cylinder and return of the piston for suction stroke. Okay, this is the four passes available in the compressor. Okay, suction, compression, delivery, and then next to suction. Okay, then I indicated work for single acting compressor without clearance. Indicated work means that how much amount of energy needed to compress the air. Okay, here work is a input. Okay, then the theoretical work PV diagram for single stage single acting reciprocating air compressor without clearance is shown in above diagram. The net work done in the cycle is equal to the area behind the net work done in the cycle is equal to the area behind the curve. Meantime, I tell the area under the PV diagram is work output or work input. In work output systems, which is work output. In work input system like VCR systems, it is work input. Okay. Then that area behind the curve, here also they are matching the concepts with in the previous old concepts. Then the area under the PV diagram or behind the curve is called work output or sorry, work input indicator. Then work input indicator, the area behind means this is the curve, then area under the curve is called work input. How much amount of energy is needed from compress from 1 to 2. Okay, this is the area 1 to BA1, the total energy needed for compression action. Then the area behind the curve Indicated work done per cycle is area became because this is area C12DC, the total area of the PV diagram. Okay, then here we have two rectangles, one is this and another one is this. Okay, these two rectangles are there, but compression takes place from 1 to 2 alone. Okay, compression takes place from 1 to 2 alone, but initial pressure is above the 0 bar because atmosphere pressure is 1 bar. Everybody knows. Okay, and also the volume that air sucks and delivers the compressed air delivers to the compressed air tank. That point 1 is here and point 2 is here. But we can fix also here 1. We can fix the point 1 at the x-axis, and also we can fix the point 2 at the y-axis. It's also possible. It means the compressor sucks the air at 0 bar and delivers the pressure at higher pressure at 0 at no clearance, no zero volume. Consider 0 volume. The first point is the air sucks the air at 0 bar. It's not possible because the atmosphere pressure is 1 bar. Okay, then then only they are fixing the limits from shifting the point 1 in y-axis to certain height. This is for P1 equal to 1 bar for atmosphere condition. And the second point is that it doesn't matches with the y-axis because that certain volume is there. Completely merged with TDC, then there is no, it is assumption for there is no air inside the compressor. Okay, this is the main important concept. Okay, point 1 and point 2 is slightly differentiated with the x-axis and y-axis, slightly so it is slightly deviated. It's slightly deviated from x-axis and y-axis because for the reason for point 1 is the atmosphere pressure is 1 bar. Okay, this therefore this not doesn't start with 0 bar. And similarly that the after compression the volume in between the cylinder top head and the piston before it delivers the high pressure air to the tank. Okay, the volume, certain volume is there because at the volume is occupied volume of compressed air. Okay, then exhaust valve is open and compressed air is escaped from the cylinder volume at the lowest cylinder volume to the tank. Okay, then the volume is gradually decreasing and it matches with the y-axis. At that point only the volume is equal to 0. Okay, therefore which is the reasons for the deviation of the point 1 and 2 from x-axis and y-axis. Okay, therefore here two areas are there. One is vertical rectangle, another one is horizontal rectangle, which is the additional work for the compression. This don't needed in theoretical, but in actual case it not possible without this energy inputs because pressure is 1 bar and certain enough volume is needed to deliver the high pressure air to the pressure tank. Okay, without that volume it is not possible to deliver the air from cylinder to tank. If you compress the piston up to the cylinder head, high compression takes place, but air is a one substance. It have it need a certain phase for its occupying. Completely matches with TDC piston. There is no space available inside the cylinder. Therefore, it's not possible because the air is a one substance. Therefore, any substance having certain occupant phase, okay, a liquid or solid or gas, both are all substance. The substance having enough space to occupy. Okay, solid is rigid, liquid is slightly rigid, and gas is flexible. But even though it is flexible, but it is a but it is a one of the substance. Therefore, it has certain or it needs certain minimum space. Okay, that space is the certain rectangular space. Okay, without this space, we cannot compress or we cannot deliver the high pressure air in more quantity. Okay, therefore the space is needed. I tell this space. Okay, then area total. These three areas are shown in figure, and area 2 P2 V2 for floor, area 1 to 2, area 2D0 B2, area 2D0 B2, rectangular area L into B, P2 V2, first area, P2 into V2. This length is V2, this length is P2, therefore the area of the rectangle is equal to LB, therefore P2 into V2. Then is a compression, isentropic compression, therefore the formula is what? Minus integral of PdV. Then this area is also rectangle, and then the area is height is P1, the width is V1. The area is P1 V1. Therefore, we have three areas. This the addition of these three areas are the total energy input to the compressor. Okay. Then the process is isentropic or polytropic process. Already I said. Okay, process 1 to 2. Process 1 to 2 is a compression process, and remaining two rectangles are for one is lower pressure limit and another one is lower volume limit. Okay, these two areas are called flow energies. Okay, flow energy. The space is for flow of air from that cylinder to atmosphere. Okay, then these are the main concepts. Then now we come to the process alone, compression process alone, process 1 to 2. Okay, here PV process theoretical process is polytropic process, which is PV power n equal to constant, n is polytropic index. Then from that minus PdV we get, then it is equal to P2 V2 minus P1 V1 by n minus 1. It's a formula for common formula for compression work. Okay, P2 V2 minus P1 V1 divided by n minus 1. So memorize this formula. Okay, for polytropic or isentropic compression work, the formula is P2 V2 minus P1 V1 divided by n minus 1. Is already studied in the thermal science at first unit. Okay, isentropic process or polytropic process. Okay, then now we also add the all areas, which is first vertical rectangular area and another PdV work, which is compression work from 1 to 2, and the bottom rectangular area P1 V1. Then P2 V2 plus P2 V2 minus P1 V1 divided by n minus 1 minus P1 V1. Okay. Then P2 V2 combine those two things. Here the P1 V1 is minus by the total area, because that P1 V1, that area is for the atmospheric condition. Okay, for that atmosphere, therefore from 0 to P1 bar there is no energy needed to rise the compression, because atmospheric pressure alone at the P1 bar, 1 bar. Okay, there is no need to rise the pressure from 0 to P1. because the base pressure or suction pressure is the atmospheric condition. Okay, therefore that area is the subtraction area because that area is the atmospheric condition. Okay, there is no atmosphere having 0 bar. Okay, in our situation, the atmosphere pressure is 1 bar. Therefore, that limit is that area covered by the PV diagram is for atmospheric condition. So, for atmospheric condition, we don't need any energy input. That means from 0 to P1, P1 is suction pressure, which is atmospheric condition. For example, 1 bar. The compression is takes place, but that compression is operated or organized by the atmosphere alone. Okay, we don't need any compressor to raise the 0 to 1 bar. After 1 to another high pressure bar only we need compressor. Okay, therefore that area is subtracted from the PV diagram. Then P2 V2, then P2 V2 and P1 V1 in P2 V2 minus P1 V1. Therefore, combine these two parameters P2 V2 minus P1 V1, then 1 by n minus 1 minus 1 we get. Then W input equal to n by n minus 1. And this n minus 1 add these two terms, which is 1 by n minus 1 minus n minus 1. Then we get 1 minus 1 cancel. Then n by n minus 1 is only available. Okay, then we get W input equal to n by n minus 1 P2 V2 minus P1 V1. This is the formula for total work input to the compressor. N by n minus 1 P2 V2 minus P1 V1 is the indicated work input to the compressor. Then using characteristic equation PV power MA RT, MA is equal to mass of air, then Wn equal to n by n minus 1 MA R T2 minus T1. Instead of I substitute MRT instead of P2 V2 in above equation. Then n by n minus 1 MAR T2 minus T1. MAR is common and T2 is different, therefore T2 minus T1 is only inside the bracket. Okay, then some more other derivation. Okay, I continue that derivation up to certain limit. Okay, then n by n minus 1 MR T1. I can take the T1 in the inside take in the T1 from the inside of the bracket, then T2 by T1 minus T1 is we get. Then use the polytropic relation. T2 by T1 equal to T2 by T1 power n minus 1. The polytropic relation, then T2 by T1 equal to T2 by T1 power n minus 1. Then T2 then substitute the T2 by T1 value in the above formula. Then we get n by n minus 1 MA RT1 into P2 by P1 power n minus 1 by n, which is instead of T2 by T1. Okay, then n by n minus 1 P1 V1 is for MRT1, then P2 by P1 is equal to n minus 1 by n. That formula is in previous formula is in terms of temperature, and this formula is in terms of pressure and volume. Okay, then we have three segment of formulas. One is the simple formula, which is a simple formula. Work input equal to n by n minus 1 P2 V2 minus P1 V1. Okay, then this is the second formula is in terms of temperature ratio. And this is third formula is in terms of pressure ratio. Okay, first is simple formula and second one formula is in terms of temperature ratio and third formula in terms of pressure ratio. But in the compressor, the pressure ratio is main important thing. Okay, therefore we know once we know the pressure ratio, then automatically we calculate the work input without exit pressure and exit temperature. Okay, pressure ratio is constant for a particular compressor. Therefore, once the value is known, then we can automatically calculate the work input, total work input to the compressor is work input to the compressor. Okay, with the help of P1 and V1 alone. Okay, there is no need to calculate or no need to measure exit pressure and exit temperature. Okay, which is the main advantage for the formula. Okay, then next thing, mean effective pressure. Mean effective pressure is already known. Work input equal to mean effective pressure in Soto volume. From that formula is discussed earlier in auto and diesel cycles. Mean effective pressure is equal to work in here. There you can use work input. Here we use work out work sorry there work output, here work input. Work input net order by Soto volume. Soto volume is displacement volume. Okay, then power and mechanical efficiency. Indicated power is equal to work input per cycle in number of revolution. Indicated power is equal to work input is calculated in previous formula, and N is speed of the compressor and K is number of cylinders. Okay, 60. Then indicated power is equal to work input equal to PM by LANK divided by 60. This same formula is used in a IC engines for calculating the indicated power. Okay, remember the that place in first unit. Okay, if they are explaining all the notations in detail, a number of cylinder in speed, and K is 1 for single acting cylinder and K is 2 for double acting cylinder. Okay, these are the main important parameters of the reciprocating gas compressors. Okay, then brake power is indicator power plus frictional power. Already said. Okay, brake power is equal to indicator power plus brake power. Then mechanical efficiency is indicator power by brake power. Okay, but here the mechanical efficiency is brake power by indicator power, because in IC engine indicator power is indicated in the cylinder and brake power is the output of the cylinder. Okay, but here indicated power is the input of the cylinder, brake power is the output of the indicator power is input. Sorry, brake power is the input and indicator power is output. Okay, clearly the brake power in the form of electricity is inputted and indicator power in the form of high pressure air is outputted. But there the indicator power is inputted and brake power is outputted. Okay, therefore it is totally opposite. Okay, there indicator power is the formula for indicator power in IC engine equal to brake power plus frictional power. But here they are telling brake power equal to indicator power plus frictional power. Okay, therefore the indicator power is a therefore mechanical efficiency equal to indicator power by brake power. Okay, so indicator power is the output. Therefore brake power is the input. Therefore always the indicator power is lower than the brake power in that compressor. But in IC engines, indicator power is always greater than brake power, because the brake power is the output. Okay, therefore the efficiency is ratio between output by input. So clearly understand the concept here. Okay, there is no confusion or IC engines and compressors. Okay, here because here through shaft we can supply the energy to the compressor, but there through shaft we can get the energy. Okay, both are brake power, but here the supply means through shaft energy is supplied. Therefore the shaft work is brake power. Therefore brake power is the input here, but there energy is outputted through shaft. Therefore here also shaft power is a brake power, but the main difference is there the energy is outputted. Therefore brake power is lower when compared to indicator power. Okay, here directly opposite. Then motor power is because the motor is connected with the compressor through shaft. Then only that the brake power is transferred from motor to compressor. Okay, then shaft power driven by mechanical efficiency of the motor. Okay, mechanical efficiency of the motor and drive. Okay, if we connect it with the gear transmission, and we can consider that gear transmission, the efficiency of the gear transmission drive also. Okay, or otherwise you can directly coupled with the motor and compressor. There is no need to drive efficiency. Then we consider only for mechanical efficiency of the motor. But in many cases, the motor is coupled with the compressor through intermediate gear drive to reduce or increase the speed of the compressor. Okay, then at that situation you can consider the efficiency of the drive also. Okay, these are the main important parameters of the single acting reciprocating air compressor or double acting reciprocating air compressor. So only one difference is the K is equal to 1 for single acting and K is equal to 2 for double acting. So only difference from single acting and double acting compressors in calculation purpose. Okay, but construction wise there is a lot of difference in between both the compressors. But calculation wise, slightly small difference in between the single acting and double acting cylinders. Okay, and without consideration of clearance, the derivation is the derivation formula is very simple, and in the formula we have three. The work output formula we have three types. One is simple, and one is in terms of temperature ratio, and third one is in terms of pressure ratio. And remaining things are the following formulas are work input, so work input or indicated work input to the compressor, which is indicator power, brake power, mechanical efficiency, and this like this formulas are followed formula for the indicator work output. Okay, this is the one type of concept, and next video we solve the clearance concept. Okay.